Hi class, this is Mr. Morris, and these are Unit 3.10 Solubility Notes in AP Chemistry. Solution formation is a little more involved than what we talked about last year, so we're going to go into a little more detail talking about intermolecular forces here. When a solution is formed, there are three processes actually that are involved. First thing, our solute to solute interactions have to be overcome. That's solute-solute interactions are being overcome. That's intermolecular forces between one solute particle and another solute particle. Also, the solvent-solvent interactions have to be overcome. So whatever the solvent is, it's usually a liquid, but whatever the solvent is, you have to break the intermolecular or the force of attraction between the solvent molecules in order to allow a solution to form. And then finally, the last thing that happens is we're going to form some interactions, and these are solute to solvent interactions. The first process is classified as endothermic. It takes some energy, it takes some work to make that happen, to break these intermolecular forces between solute particles. Second process is also endothermic because we're breaking some sort of interaction, some sort of attraction between solvent molecules or particles. And then process 3, the solute-solvent interactions being formed, well, that's an exothermic process. Anytime we're forming an attraction, that's an exothermic reaction. Let's do an example here. When pentane mixes with heptane, what attractive forces have to be broken? Well, we have LDF, London dispersion forces, between a pentane molecule and another pentane molecule. We also have to break LDFs, which are intermolecular forces here, between heptane molecules and other heptane molecule. And what kind of attractive forces have to be formed? Well, that would be the attractive forces between heptane and pentane, which again is just going to be London dispersion forces because they're both nonpolar. So what's forming is London dispersion forces between heptane and pentane molecules. What about when sodium chloride dissolves in water? Well, what attractive forces have to be broken? First, sodium chloride has to be broken apart. So the ionic bond in NaCl, that's the attractive force that holds, it's the attractive force between Na plus sodium ions and Cl minus chloride ions. The other attractive force that has to be broken is London dispersion forces, dipole-dipole forces, and hydrogen bonds between water molecules. Remember, hydrogen bonds aren't actually real bonds, so I often put quotes around them. All right, and then what attractive forces must be formed? What are we going to be forming? Well, I've got a highly polar molecule here, and I've got an ionic bond, so we have ions here. What are the types of forces that are formed? It's going to be dipole. Sorry, we usually call it ion dipole forces between two different things, between H2O molecules and Na plus ions and between H2O molecules and chloride ions, Cl- ions.